Hi, I'm Alan from Crashtest Security, and in this video, we will explore the best practices for cross-site scripting prevention and the types of attacks in modern web applications. But before that, I will give you a quick introduction to how an XSS attack is orchestrated and your benefits for preventing cross-site scripting vulnerabilities. So let's get started. In an XSS attack, the threat actor crafts a malicious script routed to the user, then executed by the application browser. It is usually perpetrated by the attacker using input fields to send crafted HTML JavaScript code to a website, which gets interpreted by modern browsers of the victim. The web application includes the executed script as part of its response as legitimate. As soon as this happens, the attacker has full access to all resources available for the current session, including cookies, local storage, form values, etc. In addition, the malicious user may also have complete control over the victim's machine. So why are you benefiting from preventing XSS vulnerabilities? If not detected and fixed on time, cross-site scripting vulnerabilities can facilitate attacks detrimental to the organization. Through XSS attacks, threat actors can easily compromise how websites present content to users. Additionally, attackers can leverage XSS vulnerabilities to seize accounts, exploit user credentials, identity theft, impersonate users, and escalate privileges. Other malicious actions they can undertake include uploading malware, phishing attacks, exposure of sensitive data, and orchestration of full-blown attacks. Since its discovery in the late 1990s, XSS vulnerability has been considered a common attack vector widely exploited by attackers. Since there are several identified gaps in the sanitization of user input, security professionals often focus on fixing cross-site scripting vulnerabilities based on two factors: type of XSS attack carried out, and programming language used to develop the application. While considering the factors, security professionals categorize XSS attacks as reflected, stored, and DOM-based attacks. The simplest type of XSS attack is where the application immediately processes and returns unsanitized user input in a search result, error message, or other HTTP responses. The application logic returns an unsafe input as part of the response, without rendering it safely or storing data generated by users. In most reflected XSS attacks, the data provided by users never even leaves the browser. Stored XSS is a steady form of XSS that relies on the application's persisting user input on the target server. Unsuspecting users then retrieve this data from the application without any sanitization or validation. Modern applications that use HTML5 allow attackers to store the malicious payload permanently on the browser, typically using HTML databases. The document object model is a platform-independent interface that defines a logical structure for accessing and manipulating documents in HTML and XML. Hackers orchestrate DOM-based XSS attacks by modifying the DOM environment on the browser so that client-side code is executed in an unsafe manner. DOM-based vulnerabilities are advanced and challenging to fix, since malicious client-side scripts do not go to the server. This makes it difficult for automatic vulnerability scanners and a web application firewall to detect them, since they don't leave traces on the server logs. Strategies for preventing XSS attacks also depend on the platform programming language used. That's why we will explore how to prevent XSS attacks in PHP, JavaScript, and JQuery. If a PHP application accepts HTML or JavaScript input, the web client executes remote scripts while rendering content. For instance, if the client side includes a JavaScript file and is not sanitized, then the PHP script output will run the command of the darwin.js script. This script will display "I'm executing" on the web page. Please check the video description for the code examples. PHP includes an inbuilt function called HTML entities that can encode HTML entities. Developers call this function to escape user-supplied HTML input. For JavaScript, developers use Unicode escape input. While PHP does not supply a function to do this, it can be done with a PHP code similar to this one. JavaScript is popular with modern web apps because it uses the document object model to create dynamic HTML pages. Unfortunately, data included in the dynamic content may consist of malicious links sent to the web server from untrusted sources without sufficient validation. Since JavaScript does not include native functions to encode HTML, developers need to create their HTML encoders. For example, to convert a string to HTML, developers should develop a JavaScript function similar to this one. The function is used in a script, as shown here. Developers should include an encoder with Unicode escapes for inputs inside JavaScript strings. A sample encoder would look similar to this example. This is then parsed inside a script, as shown here. Most XSS attacks on JQuery applications are performed when user input is parsed to the JQuery selector. Developers should use inbuilt functionalities of the JQuery editor to enable the sanitization of user inputs before they are executed in the JQuery content area. When writing code, developers should use attribute dripping and value encoding capabilities to validate scripts executed by the application. They should also use the serialization.custom and deserialization.custom editor options, as shown. Crashtest Security offers a state-of-the-art automated vulnerability scanner that allows you to easily detect vulnerabilities such as XSS attacks and take necessary precautions to prevent them. Do check it out. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for listening, and see you in our next video.